Hey guys, Miss Gosling here. In this video, we're going to talk about supernovae. And just for folks who are not used to Latin pluralization, supernovae is just the plural of supernova. So one supernova, two supernovae. We say that instead of supernovas. So by the end of the video, your goal here is to be able to differentiate between type 1a and type 2 supernovae. So let's go ahead and get started. So your IB understanding applications and skills, you need to understand what type 1a and type 2 supernovae are, and you need to be able to qualitatively describe the SNR processes for neutron capture, which we'll talk about in the next video, and distinguish between type 1a and type 2 supernovae. So let's start by talking about type 1a supernovae, because they're the more complicated ones, so I'd rather talk about them first while your brain is still fresh. So type 1a supernovae are formed in binary star systems. And when I talk about a binary star system, what I mean is that I have two stars rotating around their common center of gravity. Now, a type 1a supernova will only be formed in a binary system if that star system has at least one white dwarf. So what happens is the white dwarf is going to pull matter from its companion star until its mass reaches 1.4 times the mass of the sun. And as we know, at that point, it has reached the Chandrasekhar limit, so it's going to go supernova. These types of supernovae are really useful because they have a known luminosity. So this is just like our Cepheid variables, right? If we have a known luminosity, then we can calculate the distance of that object by using the equation for brightness. So if we compare, because if you remember, we know brightness is equal to luminosity over 4 pi times the distance from the object squared. So if we know both brightness and luminosity, then we can find distance. So like Cepheid variables, type 1a supernovae are known as standard candles. Now, the reason they have a known luminosity is because they have a known mass. We know that as soon as this star hits 1.4 times the mass of the sun, it's going to go supernova. So every single type 1a supernova has that Chandrasekhar limit mass, that 1.4 times the mass of the sun, as its mass. Therefore, its luminosity is predictable. Type 2 supernovae, on the other hand, are not nearly as predictable. So type 2 supernovae happen when the core of a massive star collapses in on itself. So these stars, as baby stars, have a mass of 8 solar masses, and of course, as white dwarfs, have a mass of 1.4 solar masses or more. So type 2 supernovae are characterized by hydrogen lines in its spectrum because the outer layers of the stars that create supernovae are hydrogen rich. And one very fun fact is that Betelgeuse, which is that guy that we've been talking about a lot in the corner of Orion, is due to become a type 2 supernova soon, which in astronomical terms means sometime in the next 100,000 years. So type 2 supernovae are the type of supernova that you guys are used to seeing. So this is a supernova that we have when a single star is heavy enough that it is not stable as a white dwarf and goes supernova on its own. This is differentiated from type 1a supernovae, which are generated by white dwarf stars that spent a large period of time stable before secreting enough mass from their neighbors in order to reach the Chandrasekhar limit and go nova. So again, when we think about a classic supernova, when we talk about the classic star life cycle, what we're talking about is this type 2 supernova. So here is our IB example question. And this question is worth 2 marks, so make sure that you make 2 distinct points. This is the most common question that IB asks about supernovae, and that is describe the mechanism of formation of type 1a supernovae. So take a moment and write 2 statements describing how a type 1a supernova is formed. Pause the video, and when you are done, go ahead and unpause it so we can go through the mark scheme together. Okay, so here's the mark scheme. So a type 1a supernova is formed when a white dwarf star in a binary system accretes mass from the companion star. So it gains mass from the companion star. And when the white dwarf star mass reaches the Chandrasekhar limit, the star explodes. And here it says due to fusion reactions. You don't actually need to write that. So this is not, we do not see other words to that effect here. So it is expected that you have the specific language when you answer it. So when you are grading this, make sure you are again, be hard on yourself. Don't give yourself the points if you don't meet the specific language that they expect from you. So let's talk takeaways. First of all, type 2 supernovae occur when a red supergiant collapses in on itself. And these supernovae are characterized by having hydrogen in their spectrum because we are looking at a star that had a lot of hydrogen in it that is starting to collapse. Type 1a supernovae, on the other hand, do not have a lot of hydrogen in their spectrum. And the reason for that is that they occur in binary star systems when a white dwarf star accumulates enough matter from its binary star partner to go supernova. And again, this happens when they hit right when that star hits the Chandrasekhar limit. Because the supernova happens when the white dwarf hits its Chandrasekhar limit, it has a known mass and therefore a known luminosity. As a result, the type 1a supernova can act as a standard candle because we have a known luminosity and can measure its brightness and therefore can calculate its distance. So there you go, guys. These are the types of supernovae that you might experience as you study astrophysics further. So best of luck and happy learning.